Hello everyone. A very warm welcome to everyone present over here. I am Namrata Hari from SRMIC Ramapuram. Hack the Mountains 2.0 welcomes you all for this 16th session of Qubits. It is really nice that all of you have taken off your time to attend this session to learn something new. Let's continue having the spirit for this event and for the upcoming events as well. We welcome you to another highly exciting session on the topic, the future of AR and VR and robotics with Sanjit Singh. This session would inspire you all to know more and delve deep into virtual reality and robotics technology. This session would be your first guided steps into the field of virtual and augmented reality. Sanjit Singh is a space coach at AFWERX, project lead at NASA Suits, and an upcoming Xboost fellow software engineer at Ensign. His experience and interest in the field makes him more than qualified to introduce you all to it. Hack the Mountains team welcomes you, Mr. Sanjit. Over to you. The stage is all yours to rock.
Thank you. Really excited to present. I'll start sharing my presentation with everyone. Just let me know if you can see, and we're good to go. Can you see?
Yes. Not yet.
All right. Just let me know when.
Okay.
Let's see. Oh. All right. Okay. Now I think you should be able to see. Can you see now?
Yeah, it's loading. Yes, we can see it.
Okay. Perfect. All right. So, as mentioned, I'll be giving a talk about the future of AR, VR, and robotics. This is really exciting time to go into it. So, yeah. So this is a little bit about me. As mentioned, I'm a student, hacker, project lead at NASA Suits, and space coach at AFWERX. I was also the co-founder and former vice president at Xboost. It was a biotech startup where we worked a lot on VR, AR environments and robotic exoskeleton technologies. I was there for a year, and then due to lack of funds, like most startups, I failed. But there's always other amazing, cool, exciting projects. And my goal is building the future of virtual augmented reality, robotics, brain-computer interfaces, virtual worlds, AI, humanoids, and really so much more cutting-edge technologies. Like there's just a lot of really, really cool stuff going on. For some of you that are interested, you can definitely connect with me here on LinkedIn or follow me on Twitter. I'm always open to, helping out people explore the field. So now I'll be going in details about virtual augmented reality. So first of all, what is virtual augmented reality? Well, virtual reality is more like, you can say, a 3D generated virtual environment in a headset where users can interact as if they were already in the simulation, as if like they're already there. And they would gain immersive experiences based on their surroundings. So like, let's say you want to go to the beach, but it's not a good day for a beach. Well, virtual reality, you can kind of feel like you're already there. The goal is basically virtual reality. It's making your mind believe as if you're already in that type of environment. On the other hand, augmented reality is more like a 3D generated computer environment where you're projecting images from a virtual world onto a real world as a hologram. So if you look to the right, basically, look at augmented reality as in like the world like Iron Man. It's all heads-up displays and holographic interactions. It's actually where one of the futures we're headed into right now for those of us that have seen Iron Man. So how did this field start? So actually, virtual augmented reality, today's generation, it's more known to the market, but it's actually been around since a very long time, starting from the 1950s to 1960s. These guys are actually the four pioneers of the early days of virtual reality. Dr. Ivan Sutherland, he's heavily regarded as the father of computer graphics, who created this first computer 3D generated software known as Sketchpad. Sketchpad was like a 3D modeling software, and a lot of the things he created about graphical rendering softwares, he wanted to explore how to actually go in an immersive world and get that immersive feeling and interact with graphical objects. So his first invention led to the very first virtual reality headset known as the Sword of Damocles. This is all from the 1960s. This is stuff that was like back then very new and still wasn't mature, but it was a really, really good start. The thing about Sword of Damocles was as immersive as it was, it wasn't as advanced as the VR we have today, but it was really, really cool stuff. Morton Helly, he actually was a pioneer in VR film. So he's the one who discovered how to use virtual reality technology for immersions in filmmaking. Now, this guy over here, all the way to the top right, Dr. Tom Furness, he's actually one of my favorite. He's heavily regarded as the grandfather of virtual reality. His work actually started with the Department of Defense at the Wright-Patterson Armstrong Air Force Research Laboratory, where he worked there for 23 years on cockpit systems. So cockpits are basically like flight controllers. So as if you were piloting a plane, you would have to know about the visual information, how far you're flying the plane, the longitude, the latitude, the magnitude, and more. It was very hard to keep up with all this information and do everything simultaneously with just a cockpit controller. And so what he decided was, as pilots were wearing helmets, he decided to invent visual display systems that can help the pilots see what they're flying through and all the visual information. A lot of that visual information also helped create virtual augmented reality and heads-up displays. So Tom Furness, he's still around in the days. He's still doing virtual augmented reality. His work has been really, really groundbreaking. And then the last guy underneath is Dr. Greg Berdea. He's actually a pioneer in virtual rehabilitation. So he's the one his work started a haptic device in robotics rehabilitation, and he figured out how to combine these with virtual reality into creating the field we know as virtual rehabilitation. Virtual rehabilitation is basically games used for rehabilitation purposes. Could be for physical therapy activities or mental health, such as, let's say, you're a soldier who comes back from war but has PTSD. Virtual reality is already being used to help soldiers with PTSD and other physical neurological conditions like cerebral palsy and multiple sclerosis and more. And that stuff will be going later in more detail as I get into the applications as well. So these are a lot of the types of different VR, AR headsets. Some of them are very expensive, and some of them I'm sure you've probably heard of, and some of them you've seen. One of them here is a HoloLens headset. It's developed by Microsoft. Very, very powerful headset. In fact, HoloLens 2 is one of their latest product. It's very, very cool and immersive, a lot more greater resolution and field of view compared to HoloLens 1. Magic Leap is another great AR headset. It has great field of view, more better graphical resolutions, and a lot of it's actually controlled with like a controller. So like you're able to interact with UI using like a joystick controller, as you can kind of see in the picture. It's kind of like a haptic feedback controller. While for HoloLens, a lot of it's purely just based off of gesture clicks. Another great headset is by a startup in China known as Nreal. Nreal is another really, really cool augmented reality headset that's, I think, using an Android operating system. Another good one is Project North Star. So Project North Star is actually combined with Leap Motion. Leap Motion is a hand tracking device, so they're actually using Leap Motion sensors for a lot of depth sensing and projecting a lot of virtual images through the headset. So these are all actually different types of augmented reality headsets. So the difference between the augmented and virtual reality headset, as mentioned, is augmented reality is bringing these virtual world environments and displaying it onto the real world, while virtual reality is more like it's doing it through the headset. So these are different type of VR headsets. I'm sure we're all familiar with Oculus. Oculus is very, very popular. Oculus Rift and Oculus Quest. Quest is the latest one. It's a lot more different between Rift is more, of course, PC VR, while Quest is more mobile VR. Google Cardboard VR, I'm sure that's another one we've seen. It's, in my opinion, not the best VR headset because mobile VR is still very limited and still a little bit niche, but I'm sure Google will work that out. Other popular VR headsets nowadays are HTC Vive and Windows Mixed Reality headset. Very, very powerful immersive experience, and a lot of it, difference between that and Oculus is Oculus also now has hand tracking and hand gestures. I think HTC Vive also is trying to come up with some of these new updates, but these are basically the futuristic and immersive headsets out there. So previous versus today's headsets. So in the first image, if you see the difference between HoloLens 1 and 2, so HoloLens 1 has 30 degrees field of view, while HoloLens 2 is 52 degrees field of view. The degrees of freedoms are also more advanced on HoloLens 2. And as if you can see the image to the left here, HoloLens 1 image, well, it's not as great. The resolution isn't as immersive and mature. HoloLens 2 is a lot more, sure you can see there's a huge difference. It's a lot more immersive, a lot more mature. It's a lot more interaction. A lot of the gesture recognitions are more different, a lot more advanced and easier to use. HoloLens 1 also kind of the screen display is a little bit smaller. It's kind of hard to see everything. HoloLens 2, it's really, really a big difference, which I can tell you from personal experience trying out both these headsets. Now, if you look at one of the VR headsets here, this is Google Cardboard. So like difference between this type of VR technology and VR in the 1960s was, of course, there weren't really multiple platforms that you could do VR for. Another thing was VR graphics rendering and resolution wasn't as immersive. It wasn't as great. It wasn't as realistic. Interaction wasn't as great as it is now. There's a lot more you can explore and get the feeling of in a VR environment that you couldn't probably get from some of the 1960s technologies. And a lot of it now is more in the market. So there's a lot of big difference between the previous versus today's headset and some of the previous headsets from today compared to the newer ones. So other areas that AR is also available in is, of course, mobile technology. So mobile AR and VR is something that, difference between them is, it's a lot more affordable because I'll be honest, not everybody can afford a HoloLens device. It's over $3,000. Magic Leap is also pretty expensive. Mobile, it's more affordable. It's easily usable. Only difference is for mobile AR, it relies on a powerful depth sensing camera and a LiDAR sensor. So this is for both Android and iOS users. So there is actually good technologies for some of you that want to be AR developers. Some of the SDKs you can use is AR Core, which would be for Android. AR Kit will be for iPhone. I'll be honest though, when it comes to AR Kit, Apple is ahead of the game because some of the cool features that Apple already has in their AR SDKs that other companies still lack is body tracking. I'll show a little bit of a video here. So this is an example of an AR body tracking toolkit with AR Kit developed by Apple. So as you see, you can do 2D tracking. As you see, the person can here do 2D tracking. It's able to a little bit detect the person's posture, geometry, angle, and joint. It still has a little bit lagging. That's just due to the depth sensing and how mature the technology is. Still needs work. But now this is 3D tracking. It's overlaying an avatar onto the person. The person's able to basically make movement, do pose estimation. 3D tracking is basically able to pick up their calculation a lot more accurately. So now this is more human segmentation. It's able to kind of like show everything from like a RGB angle. So actually, AR Kit is both available on the latest iPhones and latest iPads. So some of you that have iPhones and iPads, the latest version, AR Kit is definitely something worth exploring. Oops. So now I'm going to talk about mobile VR. Well, while it is more affordable compared to other VR headsets like Oculus and HTC Vive, it's still not mature and immersive enough. Like just mobile VR is still very limited for like many, many reasons. Immersiveness is really one of them. It's one of the main one. But the good news is, while it's affordable, the only thing you really need to run mobile VR is it only requires a phone and a Google Cardboard box. So pretty much if you have a Google Cardboard headset and a mobile phone, that's pretty much all you need to run VR. And one of the things about mobile VR is, while it may not be the best for other certain VR applications, it's definitely good for playing games in VR. So these are some of the hardware designs about VR technology. So this is here, I'm going to talk about how the construction about how VR, AR actually works and is built. So one of the core components they're using are IMU sensors, so inertial measurement unit. So IMU is basically good for orientation, calculating orientation of body sensation, velocity, rotations. So for example, head tracking, if you're moving your head from one orientation to another, and as you've seen in VR, if you move from one rotation to another, your whole field of view, your whole scene and environment moves with you. So that's what IMU is doing. Same logic applies for AR. So basically, as you move your head or your body, you tilt up or down. IMU is basically tracking all these coordinates from a geometric perspective and computing it every frames per second. Another thing is depth sensing cameras. So depth sensing cameras are basically projections. So as you can kind of see here on the HoloLens 2 camera, VR also has this very similar camera. Depth sensing is basically what's projecting the environment. So for AR, it's basically projecting the environment like into the real world. As you see at the picture at the very left underneath, this is basically more of a HoloLens display that the depth sensing camera is able to project. While for VR is basically more projecting in the inside the display. So basically through optical lenses, you're able to basically see the displays, the environment. Basically, the depth sensing camera is able to render all that stuff through. And basically, it's basically what's constructing your environment and picking up your head tracking movements. Or basically, you can say it's the reason how VR is being rendered. And same with augmented reality. Head-mounted display is another great hardware. Well, that's another hardware design feature that's also used, because a lot of that also is used for head tracking and heads-up display. So a lot of head tracking stuff is using computer vision and machine learning algorithms, because one, a lot of depth sensing is also being used to move your head for tilting your head movement. And another thing being used is, I would say, in terms of machine learning, is more basically being able to pick up your geometry coordinates. So with machine learning, they're able to track your head more efficiently and more accordingly. That's the best way to put it. In simple words is, it saves you time from doing a lot of mathematical computation when you're moving your head movement and doing a lot of the matrices and geometry coordinates. I know it's a lot of theory to get in, but let's just say machine learning is very, very time-saving when it comes to the whole mathematical computation and moving your head tracking movements. So I'll go to the next slide. So these are actually some of the applications VR and AR's really heavily been involved in. A couple of them that are personally my favorite are robotics, medicine, and brain-computer interfaces. So here I'm going to be going in details about how it's being used in every application, detail by detail. So games, of course, if some of you that are gamers, everybody loves video games, or at least most people do. So gaming industry have been adapting to use for VR recently. Like Sony has created a PlayStation VR game for Iron Man. How cool is that? Iron Man in VR. Valve is another popular gaming industry based in Seattle here. They created their own VR headset called Valve Index. So they're using their own VR headsets for their own games. And then Sony's PlayStation also created PlayStation VR, which would be what's Iron Man being used for. Another popular VR game is Phantom Covert Ops. So basically, if you want to, instead of using traditional game controllers in playing a VR game, put on a VR headset, feel like you're actually there in an environment, and you're the one from a first person point of view to being able to explore environments and play games that are like first person shooter or being a superhero and so much more. Honestly, in VR, you're really exploring different new environments and trying to be like in different scenarios and feeling like, you're that person playing different roles of characters. It's really cool. It's a lot of fun. And I think definitely VR is it's impacting game industry in a way that it's going to transform it. So here I have a little demo of one of my games I designed for VR, though I'm using it just testing it more in Unity, but I can show you a little sample of an example. So I've actually made my own version of Iron Man VR. So as you see, I'm actually able to fly in an environment, play as Iron Man. If I click on a point I'm going to shoot at, I can basically shoot a repulsor blast. Let's actually lower the volume a little bit. So basically, I'm able to be in a world where I can feel like I'm Iron Man. I'm able to explore around an environment, kind of fly. So some of this stuff it's going to be using is hand gestures for basically shooting repulsors. Another thing being used are Oculus Quest controllers. So right now I'm actually testing this more on my PC, but basically the logic would be, imagine playing this in VR. You basically feel like you're Iron Man, exploring the world, fighting bad guys, and being a superhero. So yeah, that was basically an example of like one type of game VR could be used in. There's really a lot of different type of games. Could be like in car racing, first-person shooters, superhero, and really just more. Like be creative and like some of you that are gamers, explore some VR games. So now this is very important. VR and education. So one of the great things VR is doing is recreating virtual classrooms. So some of you I know that want to be in person, and because of COVID, doesn't allow us to be in person, sadly, and want to go to school and interact with your teacher and your classmates. Well, virtual reality is kind of being used to reconstruct that environment and get everybody in a virtual room as if you were all there in person. It may not be the same sensation, but with VR, you kind of can make it in an environment that you can still see everybody, even if you're not together physically in person. Another thing it's doing is gamifying education. So, for example, let's say you're not very good in a particular subject and you really don't enjoy it so much, but you need to get through this class. Well, one of the great things about virtual reality is you can gamify some of your subjects that you may struggle with or not enjoy so much. Because the thing in virtual reality is it will create it more like a gamified educational environment for the subject. Or let's say it's a math class. You may not be the best at math or you don't enjoy it. Through VR, you can make it in a way that math class feels less like traditional pressure or less like work and more like a fun, immersive game that's enjoyable, you're interacting, and you're learning at the same time. Like, it's very important to have all these ingredients that it's fun, it's interactive, and you're learning. You're actually learning compared to like a traditional classroom setting or like the way of studying just off of books. Now, another important place that VR is being adapted in is medical schools. I think medical education is very important because for the future of doctors, doctors have to study and read a lot off of books. And I'll be honest, medical school, a lot of it's mainly just good test taking skills and memorization. And not everybody has the good test taking abilities or is able to memorize. And even if people are, you shouldn't just depend off of knowledge from a book. You should really, really be able to create an immersive real world environment where future doctors can get future training. So let's say, there's people in medical schools who want to be surgeon. While they know the information and have the good hands, they may not have the training until they go to residency and after. So VR is being already used to help medical students study anatomies from like visual immersive rendering images. Like they can actually look at the anatomy images at more details. Another thing is training you about surgery, like training medical students more in detail about how to do actual surgery as if you would be doing in real life. And a lot of things in medical education that's proven effective is students are gaining more hands-on real-world knowledge. And for people that want to be surgeons, they're going to be able to make less mistakes because they already have training doing stuff in a virtual environment. So in a way, it's training and it's educating at the same time. And students are being able to understand more about the human anatomy and physiology perspective from a VR environment. So now aerospace and defense, this is another popular topic. So military is actually already adapting virtual reality for stuff like combat training and fight simulators. Like for example, as I mentioned, for piloting a jet or cockpit systems, a lot of that stuff is being used to project visual displays from a cockpit. As you can see from the picture at the underneath to the right, where it says future cockpit research, a lot of that actually, if you can see, this has a helmet development. So the pilot is actually wearing the helmet, and as you can see, as they try to touch and interact with like some of the controllers and component to the helmet, it's able to project actual visual images. So actually, if you can see where it says future pilot's viewpoint, from the helmet, they're actually able to see all these viewpoints. So these are actually holographic images from the cockpit system that they're able to display through the helmet. So that's actually really, really helpful in not just flying a plane, but it's also helpful in like, knowing location, where they're going, targeting, and more. It's basically being able to save you time and being able to simultaneously use a cockpit system controller more effectively, more efficiently. It's saving you time in doing pretty much everything. And with visual displays, it's helping the pilot display all the general information they'd be seeing as when they'd be piloting an aircraft. So another thing now augmented reality is being used for is for tactile fighting purposes. So basically, when a soldier is fighting off in war, they're trying to get location of their enemies, trying to understand from like a field of view and degrees perspective, like where they're standing, how to calculate more, how to basically fire from a certain range angle. So if you see the picture top right, augmented reality is basically already being utilized and being adapted to help the soldier kind of understand location, where enemies located, firing range. It's a lot of that information coming from the helmet. They're also able to project it like from like the machine gun. It has something known as a red dot sign, which is using, I think, infrared sensor and like some laser light. A lot of that application. So basically similar stuff that you see in a cockpit system, they're projecting it like to on the ground field as well. So another popular thing about virtual augmented reality and applications being used in is in the space area. So NASA is actually utilizing this stuff for simulation training to train astronauts going on outer space through like virtual environment. And another thing that augmented reality is playing a role in is navigation and exploration. So space navigation on the moon is really important. Astronauts need to collect so much information, have ways to accurately navigate. And another thing they're trying to use augmented reality for is a guided tour to Mars. So basically, imagine if you were already in Mars, what you'd be exploring, how to really get more ideas about, the exploration of Mars. And really, they're utilizing overall these technology to really expand the universe. And I can tell you from personal experience that, NASA's huge in this area, how they're using their space exploration. As you know, I'm doing actually a NASA project this term where we're developing space exploration technologies through AR, which I'm going to be showing a little demo of on the next slide. So actually, there's two of them. So I'll first start with how mixed reality brings Mars to Earth. So this is a project called Destination Mars.
At NASA, we're excited to apply mixed reality technologies to the challenges we're facing in space exploration. Through a collaboration with Microsoft, we're building applications to support engineers responsible for the design and assembly of spacecraft, astronauts working on the International Space
They're actually
Station,
designing
and
basically a
scientists
whole
are now
constructing
using our
environment
Mars
as if they were
tools
already in
on
Mars
site
to
for
really
mission
explore
operations.
the environment, the navigation.
Scientists and engineers
Rovers would basically explore the environment. It's going to change the way how we actually would explore Mars.
We've taken the core of on-site and made an amazing experience that allows the public to explore the red planet. We call this new experience Destination Mars.
Mars can be a lonely place. So we've created holographic captures of an astronaut and a member of the Curiosity rover team to be our guides on this journey. And this gave us an opportunity to immortalize a hero.
Hi there, I'm Buzz Aldrin.
To help Buzz explain how we're doing science on Mars today is Curiosity rover driver Arissa Hines.
Welcome to my office.
We can put the public, the rover and Arissa together at the exact place where Curiosity made some of its most amazing discoveries.
We're looking forward to opening the Destination Mars exhibit at the Kennedy Space Center Visitor Complex in summer 2016. We can't wait to share this journey with the world.
Let's go to Mars.
So yeah, as you saw in the video, now already creating an environment through augmented reality where they can explore Mars as if they were already there. And this is helpful because once astronauts actually one day physically go explore Mars, they'll have the training and ideas of how to explore it. And augmented reality displays the application they were using for training. Hopefully they can be able to apply some of the same procedures when astronauts are actually on Mars. So on to the right side, I'll show a video of what I've been doing currently from my end for NASA. So NASA wants to explore the moon on lunar exploration more by 2024, as in they want to get more astronauts on lunar exploration. So some of the core components for designing help on exploration is geology sampling, note-taking, waypoint finding, and telemetry streaming, which is basically vitals, because the thing about space is it's important to monitor vitals because there's actually no oxygen in space, and that spacesuit has a limited amount of time that it's going to be able to give the astronaut oxygen, because then they're going to have to go back into the rocket to get it recharged. So a lot of it's based on the power sources of spacesuit and heads-up displays. So as you see, I'm actually experimenting with HoloLens 2 device for space exploration app. So one of the features I'm using right now is a note-taking feature. So this is actually a very, very old demo. This is actually the first demo I did for my NASA project. As you see, I'm able to click some of the UI buttons just with my own hands. That's a great thing.
Jarvis, turn off toggle menu.
About HoloLens is gesture recognition. As you see, I'm also being able to use voice command. So voice command is basically another feature that in case astronauts don't want to use their bare hands all the time to click on some of the UI components, voice command kind of saves you some of the time. It basically, they can just use voice command to tell the heads-up display to do stuff for them. So as you see, I'm kind of interacting with the UI. I'm trying to play around with it. So the great thing with HoloLens is a lot of it is just interaction, UI, and basically just gesture focus. A lot of it is like, it's pretty much that. It's very beginner friendly. So I'll actually skip a little bit of it. This is just me actually just playing around with the UI. Nothing too important. But as you can see, the left side, I have my geology sampling documentation. So I'm going to be showing what happens if I click some of those buttons. Skip a little bit. Okay. So yeah, as you see, geology sampling is important because when the astronauts on the moon, they're to collect certain samples on the moon. So they could be rock samples, other type of samples. It's basically, geology sampling is a component that this is a task that astronauts do on the moon. So it's one of the core components on exploring the moon, because the things they're trying to explore on the moon is not only like, samples that are there, but more rather about, they're trying to understand more about the moon and more about like how things work.
Jarvis, turn on toggle menu.
Basically, lunar mission is very much directly linked to mission to Mars. Because if we can find out
Jarvis,
more about,
turn off note taking.
If we can find more information about the moon, then we're going to be able to apply the same logic to mission to Mars. Because from what one of my NASA mentors has told me, the electromagnetism energy level on the moon is very similar to Mars. So basically, through augmented reality displays, it's going to be able to help the astronauts have ideas about what geology samples to collect with more detailed information. And astronauts themselves have aware of that knowledge. They themselves are scientists. Another thing it's going to help them with is more accurately being able to calculate waypoints, trying to find out more trajectories of being able to go from one point to another to another. Another thing, as mentioned, is telemetry streaming, so being able to monitor vitals. So augmented reality displays, it could visually be able to help the astronaut keep track of all this stuff. Because if they can visually see everything going around them in terms of calculating waypoints, there's spacesuit conditions and more, it's going to be, they'll be able to effectively do their task more efficiently at the same time. So heads-up display is basically there to help in terms of guidance. That's the best way to put it. Oops. All right, so next slide. All right, so robotics. Robotics and VR and AR is a huge area. Like, for example, VR and AR already is being used to create immersive media to operate a robot. So actually, if you look at to the right image on the top, this person is wearing a HoloLens headset and kind of understanding more about the robot in terms of like robotics performance, like how well the robot is performing, what's the condition of the robot. In fact, they're able to create environments in VR, AR for robotic simulation, as in like they can kind of test out the robot in a simulation for like scenarios such as industrial use or robotic surgery before actually doing it in a real life environment. The picture underneath is a tele-robotic device. So they're using VR and AR to control the robot. So what would happen is the person wears a VR AR headset, and through controllers and gesture recognition, they're going to be able to control the robot through the headset. It's like really, really cool. So this person here in this picture, he's actually wearing a VR headset and also has Oculus controllers. So as the person wears a headset and uses the controller, the person's actually being able to control the robot. It's like really, really cool. And in VR, they're being able to understand more about the person's environment and movement, interaction with the robot. In fact, some of you that have worked with Unity or that have never worked with Unity but want to get into robotics, Unity 3D recently released a robotic simulation toolkit. So to the robotic simulation toolkit, Unity already provides some packages and support for you to get started robotics. So they have some environments where you can like test out robotic simulation environment for stuff like industrial use. Unity also provides a robotic operating system engine, or ROS. ROS is basically, I would look at it less like an operating system and more a toolkit as you use to like kind of get started in building with robot. It's more like an integration and communication tool. So that's one area. Another hot area is robotic surgical systems. So they're combining VR, AR for this type of stuff. Like there's a startup in California known as Verb Surgical. Verb Surgical is developing the next generation robotic surgical devices, except they're also combining with VR, AR. So while VR is more simulation use, they're using augmented reality for stuff like surgical intervention. So being able to overlay an anatomy figure. So as the person overlays an anatomy figure onto the user, they're going to be able to use robotic surgery to better understand and have visual guidance on how to better effectively operate the patient through robotic surgery. So there are a couple companies doing that. Verb Surgical is one of those startups. Another startup is based in Boston. It's called Vicarious Surgical. They're basically also developing the next generation robotic surgery and combining it with VR, AR use. So basically, look at like VR, AR controllers for robotic surgery. And another big hot topic is exoskeletons. So this is another area I personally worked with. Exoskeleton devices are being utilized and combined with VR. You can look at a robotic exoskeleton device as an Iron Man technology. So they're basically, the robotic exoskeleton arm and leg would basically be like a muscular support. Exoskeletons are already technologies used in military for like for being stuff like used for. One example is like carrying heavy equipment. So heavy equipment is one thing that military is using it for. Other stuff being used by military and healthcare clinics is rehabilitation. So example is you're an injured person, you need to regain control over your limbs. Exoskeletons is being used for that. And the reason they're combining a VR, AR is not just for gamification experiences, but also to improve interaction. Like there's a lot of applications with exoskeleton and VR, AR combined. Another thing is in the therapeutic clinics, like let's say you see a patient with cerebral palsy, they got to exert more energy to do simple tasks. So exoskeletons are kind of there to provide muscular support to that patient due to physical cognitive impairments. So basically the patient is wearing the exoskeleton, and VR, AR is basically they're using it more as a gamified environment, and the exoskeleton is being used to basically combine and have the person regain control of their limbs. And the best way to do it is, instead of just having a plain old exoskeleton, you want to make therapy fun for the patient. So basically that's where exoskeleton, VR, AR is being combined in the healthcare clinics. There's many other applications that you all are welcome to explore. So in the next slide, I'm going to actually be going more into the whole healthcare clinic. All right, so medicine. So this is a very popular topic, and the medical field, the medical market is very, very complex. It's definitely should not be played with. It's definitely something to be rather explored with. And VR, AR is definitely a big resource in this. So it's been used for medicine actually a good amount of time, except it was rather more in research. It was rather more research labs were adapting to VR, AR for their own research purpose, but they also wanted to eventually get stuff to market. So nowadays, VR, AR people are trying to get it out to medical clinics. So today, there's a lot more demand for this technology. So one area, as I previously briefly talked about in my previous slide, was physical therapy. So now I'm going to expand more. So physical therapy, how is VR, AR used for that? Well, it's being used for gamified experiences, because think about it. Video games are being heavily involved in VR and AR. In medicine. VR and AR is a big tool because it provides immersiveness, more interaction, and really, you want to have certain types of games that involve exercise games that involve movement with your limbs and your arms. You want to be able to move your body in a way that you can regain control. So, for example, physical therapy, patients with neurological conditions ranging from strokes, cerebral palsy, multiple sclerosis, Parkinson's, seizures, and even orthopedic rehabilitation. A lot of these, are unfortunate conditions, but, the old way of therapy is kind of like, it's more repeated tasks, repeated iterations. Patients don't feel motivated when they have to do the same thing over and over again, and they want hope and they want things to be more fun. So VR is being used to basically develop games for patients, so patients are more motivated and engaged to do their therapy. And one of the biggest challenges, you keep after coming up with new ideas for new games every month because you don't want patients to stop doing their therapy. So the goal at VR AR is to make therapy more engaging for patients with physical and neurological conditions so that patients don't stop doing their therapy, and therapy is more fun, it's more efficient, more effective. So look at it like this: you're taking the entertainment concept of games and using it to solve a real world problem. And VR and AR is very good with that because it provides so much rendering, so much realism, so much interaction. And VR AR is just one of the core technologies. As mentioned previously, robotic exoskeleton is basically the big cherry on top. Combining all this together, you're basically creating Iron Man, but rather for social good use in the whole healthcare field. Now, mental health is also important because conditions like autism and PTSD. So, some patients with severe autism don't have awareness of their whole environment, don't have necessarily the social skills. So VR AR is being adopted to help autistic patients out, being able to gain more awareness in their environment, rather more skills on social aspects. So, this is just naturally, that's the whole thing with, it depends on a level of autism. Some patients with autism, may not have severe issues. It may be mild, but they still may lack social skills. So they're developing VR, AR gamified environments to teach autistic patients how to better improve social skills, while autism for people with very severe conditions, they're trying to create environments in VR, AR to hopefully teach neurorehabilitation to the autistic patient about how to have better aware of their surrounding and environment. This is still experimental and new stuff, but it's definitely, VR has come effective to autistic patients for social aspect, and hopefully will come more better use also for awareness. Another important thing is also, like, as I was mentioning about PTSD, is, so imagine you are a soldier. You are a soldier coming back from war, and you experienced so much killing. You were one of those soldiers who had to see a lot of dropping dead bodies, and you were one of those fighting soldiers who also had to kill some people. Well, of course, coming back from war is not easy. It's going to be very traumatizing. And a lot of soldiers that come back from war, they come back as different people. They cannot get over the fact of what they saw. So they're using virtual reality for this in order to recreate an environment for the soldier to relive these experiences and better come up with techniques and neurorehabilitation ways to help the soldier get over their experience of what they saw in war. So VR has actually been heavily used for PTSD use. In fact, there's a very famous professor. His name is Skip Rizzo. He's a professor at the University of Southern California. He does a lot of work with virtual reality for mental health for PTSD, trying to rehabilitate the soldier from what they saw. So a lot of his research has involved recreating war scenarios in a virtual environment where the soldier relives the experience of what they saw. And as the soldier relives the virtual experiences, with VR, they're trying to basically come up with techniques in a way they're trying to tell the person, you got to get over this. This is what you saw in the VR environment. I know it's a lot, but basically the more you make person relive it through VR, the person actually tends to be more calmer because their brain is basically stuck in a world where it's more like, it's interactive. They're distracted from their actual problems. So VR is basically being used to help distract person with PTSD. And another thing I should have brought up on here is phobias. So VR is being used to help treat phobias. So for people who have fear of spiders, well, they're creating a virtual environment where patient is basically interacting with a spider. So basically, the more the person tries to interact with a spider, gets over the spider, they're like, okay, it's a spider, get over it. I know you're scared of it, but they're recreating a virtual world where a person is in a room surrounded with spiders, and basically as the person sees the spiders more and more, they're basically trying to make it in a way that the person gets over the fear. And actually University of Washington did this type of research, and it came out effective that the more they put the VR headset on the person seeing more and more spiders, and since it's not real in VR, the person was able to be like, all right, I get it, there's nothing to really be afraid of, it's not real. So if they're not able to be afraid in a virtual environment, can that same logic apply in a real environment? So VR has come very effective for that. Now, another thing is pain reduction. So actually distracting a person's mind from severe pain. So one example is chronic pain. And another example is, let's say you were a soldier and you were severely injured from war, and the doctor has to amputate your limb because there's no other way they can save your life. While amputation is unfortunate, it has to be the case. So as the doctor amputates a soldier and the limb is already cut off, patients' brains actually start simulating a sensation of this pain known as phantom limb. Phantom limb is basically a neurological pain, as if after a limb is being cut off, the patient still experiences the exact same pain as if the limb was actually never cut off. So this is actually known as phantom limb. You're experiencing severe pain after the limb was amputated, as if it was never cut off. So as patients experience severe phantom limb after amputating a limb, virtual reality is already being used to reduce that pain by putting the soldier in an environment. It doesn't have to be a gamified environment. It could be like a nice environment, like on the beach or wherever. They're distracting the person from that pain, and rather not have them think about the pain too much, and rather through VR, they're making the person wear a headset. So as if they were, already going through phantom limb, VR is already being used to distract a person's mind from pain reduction. So that's basically where pain reduction plays a role for phantom limb patients. Another big thing VR and AR is being used for is surgical intervention and guidance. So I mentioned that briefly. So surgical simulation is one thing. So let's say you were a doctor and you do surgery every day. Surgeons tend to make a lot of mistakes because they're overworked, they're very burned out. So of course, it makes sense. But surgical simulations are basically a big thing in VR and AR, because now doctors are basically having ways that they can have a game. So a surgical simulation like a game for them, where they have to operate on a patient in a virtual environment. So basically, the more and more surgeon was to get training from a surgical simulation in a virtual environment, the goal is the more mistakes they were to make in a surgical simulation, hopefully in a real world environment, they'll be able to make less and less mistakes. And then surgical intervention guidance. So that's where more augmented reality plays a role. So I can tell you from one of my research I was doing for the biomedical engineering department a couple of years ago, it was in military medicine. So let's say you were a soldier in war and you were severely shot and you needed to get surgical treatment to get the bullet out of your wound. Well, surgical intervention with augmented reality is good, because then you would basically have an overlay anatomy of all the parts and organs, which would accurately be able to visually help the doctor in being able to treat the soldier based on anatomy overlay and pose estimation. So in the next slide, I will be showing a little demo. So
put your right hand up.
This is actually one of my research. So as you see, I'm putting as I move my body,
push left hand slowly up.
The anatomy overlaid on me is able to mimic some of my movement. So basically, the goal of this was to create an overlaying anatomy figure along with pose estimation techniques.
I'll leave it there for
to
a
help
sec.
doctors treat soldiers on the
Bring
ground.
it back down.
So a lot of this research I was doing was for the military. So as you see, I'm slowly moving my arm, and the anatomy is trying to stay in my pose. It did have a little bit lag,
Remove
but
skeleton.
that's just due to depth sensing scan
Remove
of all
bone.
lens. And of course,
Show bone.
capability, some of the speed and rendering was a little slow.
Do a T pose slowly.
So some of the stuff I also had was voice commands. So you can basically, if you don't want to see other anatomy of the organs because it's covering up some of the stuff that you're trying to
Now bring it
work
back
on.
down slowly.
You can use voice command to turn some of that off. So yeah, there was a little bit of lag. That's just due to HoloLens rendering and capability. But again, this was all probably also because we were using the HoloLens 1.
Remove vein.
Instead of the
Remove
HoloLens
artery.
2.
Remove heart lumen. Remove digestive system. Remove large intestine. Remove small intestine. Now go T-pose again.
So yeah, as mentioned, the whole human anatomy that's overlaid on me, it's basically
it's like glitching out.
It's basically trying to
Bring it back down.
It's trying to kind of like mimic my movement, follow along.
Show large intestine. Show small intestine. Remove cartilage.
Actually, we can skip a little bit of it.
Show bone.
We can skip a little bit of
Go, that's good.
So yeah, as you're seeing, this is basically an interventional guidance display to help surgeons
remove bone.
Treat me. Let's say if as I was a soldier, I was shot on the ground, the goal would be surgeons would be able to overlay this
show heart
anatomy
lumen.
Onto me, and based off my
remove
pose,
large intestine.
Basically,
remove small intestine.
That would determine how
show
the
stomach.
soldier will act. How the
remove
doctor
stomach.
will be actually treating the soldier.
Remove artery. Remove vein.
So yeah, some of the things that lacked was also being able to, as you saw, being able to actually capture my pose, being able to move at the same speed I do, and it did lack some disorientation. But as I mentioned, again, that could have also been because we were using HoloLens 1. If it was with the 2, maybe different story. But yeah, I think you guys saw a lot of, I want to go more into the video because I think you guys probably want to see more. So the next application, this is huge. Brain-computer interfaces. Look at this like what you see in the sci-fi movies, because virtual augmented reality is literally the future of sci-fi. It's literally bringing the sci-fi reality that we've all lived in. It's all bringing the sci-fi reality and fantasy we've all lived in for such a long time. For movies we saw like Star Wars or Star Trek or Iron Man, all this sci-fi stuff you basically, Normal is creating the next generation of VR, AR, and combining it with brain computing interfaces. So the image to the right, all the way to the top right here, this is a Normal device. They're wearing a VR, AR headset, and this VR, AR headset is also wired up with electrodes. So those are EEG sensors that can kind of read your sensory input movement of the brain and compute your neural activities in real time. So what Normal is trying to do is basically they are creating a world without any limitation. So basically, let's put it like this. You're wearing a VR, AR headset wired with EEG sensors. So let's say instead of like you're playing a game, instead of using a traditional game controller or any controllers, you're just playing you're playing a game wearing a VR, AR headset wired with BCI sensors. So look at it like this. Instead of moving the player with the controller, you just think from your brain that you're going to move the player. And based off your neural activities, the headset will actually compute and make the player move just from your neural inputs, just from your brain thinking. So I'm going to show a little brief video about it here. So as you see, this user here is actually just thinking. He's doing everything off his brain, off of thinking, off his brain input. Some EEG sensors wired on top of it. So these little blue wires you see, these are actually containing electrodes. So this is basically the future. This person is selecting different objects, trying to move everything. This is just off of thinking, just normal inputs, nothing else.
So what do you think? Are you ready to play the game?
So yeah, the person was just playing a game just by thinking off of it instead of using any controllers. That is something that's really, really futuristic. And as mentioned, Norval's goal is creating a world without any limitation. So another example with this VR, AR, BCI controlled device would be, let's say, a handicapped person on a wheelchair, has difficulty moving. So instead of even just using their arm, just think of themselves moving, and the headset will actually compute that. So there's really, really a lot of cool stuff. And some of the stuff I can tell you about Norval, how they're doing it with EEG sensors is, of course, they're using hardware sensors like EEGs, but a lot of it's also using machine learning algorithms, which is computing a lot of data sets off of the brain. So it's using a lot of different neuro data sets of how the perception and thinking of the brain is working. And then the virtual environment is basically more the interaction and like the application that it's being applied to. So it's basically using combination of brain-computer interfaces, AI, machine learning, and virtual reality. It's really, really, really some futuristic stuff. And Norval they're ahead of the game, and they're also a startup based in Seattle. So to wrap this up, there are a lot of places that are doing the future work in VR AR. So MIT Media Lab is actually one really, really great lab. It's MIT, of course. MIT is, of course, going to be ahead of this kind of stuff. They have multiple different groups from VR, AR to neural prosthetics and like robotics, and they're combining a lot of these technologies to create not just interaction, but something that's like in the movies. And I'm sure there's a lot of research stuff that they're not going to disclose. Even I don't know about all their research projects, but I can definitely mention a couple of their environments they've worked on is interaction VR, robotics VR, neural prosthetics, and more. Carnegie Mellon Robotics Institute, they're basically developing the next generation of robots from humanoids and surgical use, and VR, AR is another big thing they're furthering in their lab. So they're another big place to really look into. University of Washington, they're basically all about the VR, AR. They got just too much research. One of the early pioneers I was talking about, Tom Furness, who's the grandfather of VR, he's actually now a professor at University of Washington. He's working on many, many different technologies and runs different organizations. Verb Surgical is another great company, as I previously mentioned, combining VR and AR with robotic surgical use. Magically, they're basically developing the next generation of augmented reality headset. Hanson Robotics, they're basically the humanoid robotic company. They're starting to adapt a little more into VR, AR now. They're still using some computer vision and machine learning, but they got future plans for this stuff. They're basically developing the next generation of humanoid robots, like bringing humanoid robots to life, like humanoid robots that have human cognition, human perception. In fact, if some of you have heard of Hanson Robotics, I'm sure we heard of humanoid Sophia. She was the first humanoid robot to become a Saudi Arabia citizen. Cura Technologies is another great company. They're also working on next generation augmented reality headset. Difference between them and all the other companies is they're coming up with lighter headsets. So they're actually doing similar stuff to what Nreal here is doing. So they're basically competitors. They're coming up with more lighter and scalable augmented reality headset, like literally the size of my glasses. Also VR is basically building the future of orthopedic surgical simulation VR. So basically, they're developing virtual reality use for orthopedic surgery. So basically, they're developing simulations to better train orthopedic surgeons to treat injured people and more orthopedic surgical applications. So they're basically working on a lot of new virtual reality simulations to better assist orthopedic surgeons. Norval, as previously mentioned, they're ahead of the game in like the BCI, VR and AR, the next generation of brain computing interfaces. Potentially, I can see them as maybe either a collaborator or competitor with Neuralink. Neuralink, they're more implantable BCI, but the way Elon Musk is doing stuff and Neurable is doing, let's just say there's going to be a big potential. NASA, of course, space application. Space is a very hot area, and VR AR is being used from not just in space exploration, but another area is space health. So the thing about space health is, astronauts come back from space, they experience physiological disorder due to gravity difference in outer space. So VR AR is being used for health structural monitoring in real time when astronauts are in space. So it can go from navigation, exploration to health structural monitoring, and when astronauts are back on Earth, VR AR is being used to help better assist them in regaining controls of their limbs just due to physiological disorders and symptoms. Nreal, as mentioned, Cora Technologies competitors, developing a next generation augmented virtual reality headsets that are more the size of literally my glasses here. Epic Games and Unity. So Epic Games and Unity, I'm sure Unity is a game engine. Epic Games is not just a game company. They make their own game engine known as Unreal. So they're basically further developing virtual reality SDKs or libraries and ways to put it. So for those of you who want to be VR developers but don't know where to start, well, there's SDKs to help get you started and learning more, exploring about developing with VR and AR. And some of these SDKs, they still need more work. They have problems, but these companies are basically developing more efficient SDKs to bring in more, not just Unreal and Unity developers, but the next generation of VR, AR developers. And then the last startup I'm going to talk about is Medivis. They're basically developing augmented reality solutions to help surgeons treat patients with cancer. So they're developing augmented reality solution for cancer treatment. So basically, augmented reality solution to help guide doctors in treating patients with cancer. So it's basically surgical interventional use. So these are a lot of the big organizations that are going big into the VR AR space. There's really, if some of you want to get involved, go. I definitely say go for it. I'm also still exploring the field myself too. Learning never stops, and really, there's big potential. And if you want to go into VR AR, I'm going to tell you right now, go for it. There's a big demand, a lot of money in the market, and really a lot of opportunities. So go for it. Go crazy. A famous quote by Steve Jobs, he would always say, stay hungry, stay foolish. So really, go crazy. Let your imagination go wild. And from here, I'd like to thank you all for listening.
That was an amazing session. So now, if the audience have any questions, whenever they listen to this workshop, they should definitely reach out to you through LinkedIn, maybe with a short note saying they want any mentorship or anything. They should definitely reach out to you to know more about AR and VR.
Absolutely. I'm more than happy to, help them. This is a great time to get into the field. There's a lot of big applications in VR, AR. Some people that work in machine learning, experiment machine learning, VR and AR. Computer vision, experiment with it. These are even I myself. I admit I still have very little knowledge of the field. I just have enough experience to talk about it. But there's a lot of learning you're going to be doing. Even if you want to become an expert at it, by all means. And even after then, the learning is never going to stop.
Yeah, that's so true. So I guess we'll wrap up. Thank you, Mr. Sanjit, for taking your time off your busy schedule for being with us here today. It was really cool how you talked about the awesome space health projects and even the fun Iron Man technology with examples. AR, VR, robotics are growing at such a fast rate, and it's really mind-boggling how it will be our near future soon.
Yeah,
I'm sure. Mm-hmm.
It's literally what the sci-fi movies. Imagine with virtual game pods and you're it's going to really make things go wild.
Yeah, it is. So yeah, I'm sure that our audience would have loved listening to this session. I guess all Avengers fans and all that sci-fi movies fans would have been all so excited. Yeah, we're gonna do it and all stuff. I really enjoyed listening to today's session. So yeah.
Thank you. You know, one thing I definitely say, you want to be Iron Man or next Elon Musk, innovate, just innovate.
Yeah, okay. So before we sign off, I would like to mention that the feedback form link will be posted. So do fill it up soon so that you are eligible to grab your Hack the Mountains participation certificate. It was really nice to have you, Mr. Sanjit. Also, stay tuned with us for the next session. See you all soon. Thank you for being today here with us. Bye, everyone. Have a wonderful evening.
Thank you.
Thank you.